Swayam Prabha. Digital India. Educated India.
Hello all, welcome back. In the previous lecture, we have derived the Green-Amt equation for infiltration. We have considered the fundamental laws, that is the continuity equation and also momentum equation. Finally, we have combined those two equations to form the final Green-Amt equation. So, while deriving Green-Amt equation, we have assumed certain conditions, that is, the infiltration is taking place in the presence of abundant quantity of water, because we have assumed a ponding depth. In the case of a rainfall occurring, when we will be getting a ponding depth, water will be getting stagnating on the surface when all the pores present within the soil are filled with water, right. So, initially soil will be comparatively in a dry state. In that state, rainfall is occurring and water which is falling as rainfall will be infiltrating into the ground. And once the surface layer becomes saturated, then water becomes stagnating on the surface of the ground. Then only we will be getting a ponding depth. The equation which we have derived is giving the potential infiltration, that is sufficient quantity of water is available to us. And the second assumption was, we have assumed a sharp wetting front, that is the wetting front is dividing the soil strata into two zones, that is unsaturated region below the wetting front and the saturated region above the wetting front. Initially the soil was dry, and when rainfall started, water started infiltrating into the ground and the soil started becoming saturated. And the boundary which is separating the soil which is in the initial state and after the rainfall the saturation taken place, that is the wetting front. That wetting front we have considered as a sharp wetting front. Otherwise, we have already seen the soil moisture profile. In that case, what we have seen, we are dividing the subsurface zone above the wetting front into 4 zones. At the top we are having the saturation zone, then comes the transition zone, transmission zone and wetting zone. As the water starts infiltrating into the ground in the downward direction, we have seen different zones present beneath the ground surface. But while deriving the Green-Amt equation, we have not considered 4 different zones. We have assumed that above the wetting front we are having the saturated zone and below the wetting front we are having the unsaturated soil which is in the initial condition. So, we need to have a clear understanding about ponding. Ponding process, what is meant by ponding? It is clear, that is water is getting during the process of rainfall, water is infiltrating, all the pores are getting filled up with water and water starts stagnating on the surface of the ground. But when this ponding will be starting? So, regarding that we do not have any idea. So, in this lecture we are going to understand what is meant by ponding time. So, this lecture is related to ponding time. We know in the case of potential infiltration, sufficient amount of water is available for infiltration. Now, when sufficient amount of water is available for infiltration means all the pores present in the soil can be filled up with water. Then a saturation zone will be produced and water starts ponding on the surface. So, ponding time is defined as the time elapsed between the time at which the rainfall begins and the time water begins ponding on the soil. So, we are getting rainfall at a particular time. At that particular instant, we won't be getting ponding. So, once infiltration starts in a near surface, pores present in the soil gets filled up with water and it has reached the porosity value, that is the soil moisture has reached the maximum value, that is the porosity. Then the surface layer becomes saturated, then the ponding starts. So, the time at which the rainfall started and when the ponding starts. So, the time gap between the beginning of the rainfall to the ponding moment, that is the ponding time. Before the ponding, that is when we are getting the rainfall, infiltration process is started. Just before the ponding, we will be having infiltration rate is equal to intensity of rainfall. That is, whatever rainfall we are getting, which is having an intensity I, all this water will be getting infiltrated into the soil. So, our infiltration rate F will be equal to I, that is the rain which is falling is infiltrated into the ground fully. And after ponding, infiltration will be potential infiltration. After ponding, what will happen? The sufficient quantity of water is available to the soil. So, the infiltration will be continuing, that infiltration will be potential infiltration. So, we will be having infiltration rate F is equal to F potential. Now, it is very important to determine the ponding time, then only we will be getting idea about how much is the quantity of water infiltrated just after ponding. So, we need to determine the ponding time to determine the infiltration after ponding has occurred. So, for getting an idea about ponding time, Main and Larsen in the year of 1973 presented a method for the determination of ponding time using Greenamt equation. We know what is Greenamt equation. What Main and Larsen has done, they have provided an equation for ponding time by making use of the Greenamt equation. So, in this certain principles are involved, three important principles are involved. They are, for T less than Tp, all rainfall is infiltrated. So, initially soil was at a relatively dry condition. So, time less than Tp, whatever water is falling as, whatever rainfall we are getting, everything will be infiltrated into the ground. When T is less than Tp, ponding has not reached, time is less than that of the ponding time, then whatever rainfall is occurring, completely it will be infiltrated into the ground. Second condition is that potential infiltration rate is a function of cumulative infiltration. Larsen and Main has derived the equation based on Greenamt equation. So, definitely infiltration rate is a function of cumulative infiltration. So, infiltration rate, specifically we are mentioning potential infiltration rate because Greenamt equation is derived on the assumption that there is a ponding depth of H naught. So, definitely we will be experiencing the potential infiltration. And third principle is that ponding occurs when potential infiltration is less than rainfall intensity, that is small f is less than or equal to I. If small f is greater than I, infiltration rate is more than that of intensity of rainfall, entire rainfall will be infiltrated into the ground. After certain time, what will happen? Infiltration rate will be reducing. So, that will be lesser than that or equal to intensity of rainfall. At that moment, ponding occurs. That is, when rain is falling at a higher rate than the infiltration rate, then ponding occurs. This is the condition. This thing should be very clear. Rainfall intensity is lower than that of infiltration rate. Entire rainfall is getting infiltrated into the ground. If the rainfall is at a higher intensity compared to the infiltration rate, then ponding will be starting. So, for deriving the concept of ponding time, we need to look into the soil moisture profile again. that is moisture content variation before, during and after ponding. So, the same soil moisture profile I have drawn over here with our soil moisture along the x-axis and depth beneath the ground surface is marked on the z-axis. Now, the maximum soil moisture can go up to eta, porosity, and before the rainfall starts or during the initial condition or the soil is in the unsaturated condition, then the soil moisture present in the soil will be less than that of eta. Consider the case in which T is less than Tp. T is less than Tp means the ponding has not reached. When T is less than Tp, our soil moisture profile will be like this. Rainfall started, time less than ponding. So, some of the water is getting infiltrated into the ground, but all the pores are not filled up with water. So, soil moisture prevailing within the soil will be less than that of the maximum amount of soil moisture. That is, theta will be less than eta. So, we can experience a soil moisture profile like this. Blue curve is before the ponding. The curve which is drawn is before the ponding. In that case, the moisture content will be less than maximum moisture content eta, and the time will be less than Tp. So, time is less than Tp we have considered. Our soil moisture profile will not be touching the maximum soil moisture. Now, consider the time at which T is equal to Tp. At time T is equal to Tp, the maximum moisture content eta will be attained. That is, ponding occurs. That means all the pores near the surface are filled with water. So, entire pores have been filled with water. So, the soil moisture has reached its maximum value eta. So, the curve will be looking like this green curve. When T is equal to Tp, on the ground surface there will be saturation condition. Beneath the ground surface it will be still unsaturated, but we are talking about the surface layer of soil where direct rainfall is occurring. So, that layer of soil will be saturated, and when the ponding has occurred, the wetting front starts to move down or the saturated zone increases. So, at the time T is equal to Tp, we are having the saturated zone near the ground surface, and the rainfall is continuing in such a way that ponding has already occurred, and what will happen? There is no chance of increasing soil moisture beyond eta. So, the maximum soil moisture has reached at that particular level. Only thing which will be taking place will be the wetting zone or saturated zone will be increasing. Wetting front starts to move downward by increasing the saturated zone. So, the soil moisture profile will be for T greater than Tp, it will be looking like this. Maximum value of soil moisture is still at eta. It cannot go beyond that. That is it depends on the pores which are present in the soil. So, based on that, it is already fully saturated at time T is equal to Tp. When T is greater than Tp, what will happen? This wetting front will be moving in the downward direction by increasing the saturated zone. Now, at T is equal to Tp, F is equal to I and Fp is equal to ITP. That is, time T is equal to ponding time. At that time, infiltration rate can be assumed as equal to intensity of rainfall. So, what will be the cumulative infiltration? Intensity of rainfall is I, this I centimeters per hour, and we are having Tp equal to certain hours. So, ITP will be giving you the total amount of water which is infiltrated into the ground. So, cumulative infiltration is equal to ITP at the time T is equal to Tp, with the assumption that infiltration rate is equal to intensity of rainfall. We have derived the equation corresponding to infiltration rate by making use of Greenamt principles. We can make use of that. So, according to Greenamt equation, infiltration rate is given by K multiplied by 1 plus psi delta theta divided by capital F. So, here what we are going to do, we are going to substitute for F is equal to I and capital F is equal to ITP. Our intention is to find an expression for Tp, ponding time. So, what we have done at the time of ponding, intensity of rainfall will be same as the infiltration rate. So, with that assumption we can calculate how much is the cumulative infiltration, that will be I multiplied by Tp. By making use of Green-Ampt equation, we can find out ponding time in this way, that is F is equal to I, we will be substituting small f is equal to I, intensity of rainfall, and capital F, that is the cumulative infiltration, is substituted as I Tp. So, that is substituted over here. I is equal to K multiplied by 1 plus psi delta theta divided by ITP. Our intention is to get the expression for Tp, that is I is equal to K plus K psi delta theta divided by ITP. K we can take towards the left hand side, therefore I minus K will be equal to K psi delta theta divided by ITP. So, from this expression for Tp can be obtained like this: Tp is equal to K psi delta theta divided by I into I minus K. This is a very simple expression. So, you are having K psi delta theta divided by I multiplied by I minus K. So, Tp is a function of hydraulic conductivity K, soil section psi, delta theta soil moisture deficit, and I is the intensity of rainfall. So, the equation which we have utilized here is the Green-Ampt equation. By making use of the Green-Ampt equation and assuming the time to be equal to Tp, at time equal to ponding time, what is the condition? Intensity of rainfall is equal to infiltration rate, and then we can calculate the cumulative infiltration as I multiplied by Tp. Making use of that, we have found out the expression for Tp, that is the ponding time, and we found that the time is a function of hydraulic conductivity, soil section, soil moisture deficit, and intensity of rainfall. This equation Tp is equal to K psi delta theta divided by I multiplied by I minus K. This is the equation for ponding time Tp and a constant rainfall intensity using the Green-Ampt equation. We have assumed a constant rainfall intensity I. That is an assumption, always it may not be constant, but short interval of time we can assume it to be constant. So, under constant rainfall intensity we can calculate the ponding time by making use of this equation. Now, we can have a look into this particular equation which we have derived for Tp. Tp is equal to K psi delta theta divided by I multiplied by I minus K, and we found that Tp is function of all these parameters. So, higher K value, if K value is high, definitely it is clear that Tp will be higher, and when psi is high, soil suction is high. What does it mean? Soil suction or the negative pressure is high means the soil is almost in a dry condition, or it is towards the relatively dry condition. So, if it is dry, physically you look at the soil, dry soil will be having more infiltration. So, whatever rainfall is occurring, it will be getting infiltrated into the ground until it becomes saturated, right. So, as the psi value is high, Tp also will be high. So, psi is coming on the numerator, so Tp also will be high. Higher the psi value, higher the ponding time. Next term is delta theta. So, delta theta is the soil moisture deficit. If the initial conditions are such that we know delta theta is represented by eta minus theta I. Eta minus theta I is the initial moisture content. So, eta minus theta I is the amount available pore space for water to be filled. In the case of theta I, if theta I is higher, high value of theta I is there, initial moisture content is very high. So, the value corresponding to soil moisture deficit, that is eta minus theta I, will be less. So, if eta minus theta I is less means, that is delta theta is less means Tp will be lower. So, higher the initial moisture content theta I, lower will be the ponding time. One more factor is there, that is the rainfall intensity. If I is higher, Tp will be lower, because intensity of rainfall is coming in the denominator. So, I is higher the value of I, the factor which is calculated for Tp will be lower. That you can understand, heavy rainfall is occurring, easily we will be getting ponding and after that overland flow. In the similar way, soil is having some very good amount of soil moisture content. So, more and more water will not be infiltrating, early ponding will be taking place. That is what is mentioned by this condition. Now, we need to find out the expression for infiltration after ponding. That we are going to do by making use of Green-Amt equation. Green-Amt equation is given by this particular equation, F minus psi delta theta ln 1 plus F by psi delta theta is equal to KT. So, here in this case, what we will do, for T we will be substituting Tp, and when the time is equal to Tp, ponding time, what is the infiltration? We can represent it as potential infiltration Fp. So, at time T is equal to Tp, we are replacing F by Fp and T by Tp. Same equation we have replaced by, instead of F we have substituted Fp, and instead of T we have substituted Tp. Now, what we are going to do, this F is this particular equation, let it be 1 and let this be equation 2. So, you can see infiltration after certain time, T may be very high or it is beyond Tp, T is greater than Tp, the infiltration can be calculated by using equation 1, and if the time T is equal to Tp, it can be calculated by using equation 2. So, if you are subtracting equation 2 from equation 1, F minus Fp, that will be giving us the amount of water getting infiltrated just after ponding started. So, we are going to subtract equation 2 from equation 1 for getting infiltration after ponding. So, F minus Fp minus psi delta theta, and we are having two terms, logarithmic term in the first equation and second equation, that we give it, that will be taking the form ln 1 plus F divided by psi delta theta minus ln 1 plus Fp divided by psi delta theta is equal to what? K multiplied by T minus Tp. Equation 2 is subtracted from equation 1 for obtaining the amount of infiltration taken place after ponding. Now, look at this logarithmic term that we can make in a simplified form. So, that is considered, it is ln A minus ln B, that is nothing but ln A divided by B, and some more readjustments we are doing, that is ln psi delta theta plus F divided by psi delta theta divided by psi delta theta plus Fp divided by psi delta theta. So, psi delta theta from here and here will get cancelled, and we will get the expression of ln psi delta theta plus F divided by psi delta theta plus Fp. So, what we are going to do, we are going to substitute this expression for these terms, these logarithmic terms. So, the equation will be taking the form F minus Fp minus psi delta theta ln psi delta theta plus F divided by psi delta theta plus Fp is equal to K T minus Tp. So, here we are having the difference F minus Fp, that F minus Fp will be giving us the cumulative infiltration or the quantity of water which is infiltrated after the ponding time. This is the final form of Green-Amt equation for infiltration after ponding. So, in case we are going to calculate the infiltrated amount after ponding has taken place, we can make use of this particular equation. Infiltration expression for a particular time T is written, and we will be calculating Fp, that is the infiltration corresponding to T is equal to Tp. By using Green-Amt equation, difference between them will be giving us the quantity of water which is infiltrated into the ground after ponding has occurred. So, this typical part related to ponding ponding time is taken from the textbook of Applied Hydrology by Venti Chow and others. So, in this we have found out the expression for infiltration after ponding by making use of Green-Amt equation. Certain principles are involved in this. One is at time t is equal to Tp, we are assuming intensity of rainfall is equal to the infiltration rate F, and by making use of the Green-Amt equation. Green-Amt equation is, we know it is for the ponding depth H naught, that is we are getting the potential infiltration. So, infiltration rate is, potential infiltration rate is a function of cumulative infiltration. So, with these principles, by making use of the Green-Amt equation, we have derived the expression for infiltration after ponding. Thank you very much.